first session of OOPS for the Melting Point series. We'll be starting off with Unit 1 in OOPS, which is a basic introduction to C++ and object-oriented programming in it. So before we start, let's look at what programming paradigms are. So essentially, paradigm simply means a way of coding. So you will end up with the same like solution or answer or whatever you try to code, but it's just different ways of going about it. So mainly you would see five different ways. That's imperative, procedural, object-oriented, declarative, and functional. I'll go through all of them one by one, but essentially we'll only be looking at object-oriented because this is object-oriented programming. And we'll be comparing it with procedural. Procedural coding is simply something like Python. You'll do it step by step. So imperative simply means imperative programming simply means something like, how do I put this? It's event driven in a way. It depends on many like clicks or inputs, actions, something like that. And then you have procedural, as I said, it's step-by-step instructions. And then object-oriented. Object-oriented is what we're looking at mainly. It mainly focuses on objects and classes. We will go into that in detail. We also have, so this is how data is stored, and then with these we have functions. But yeah, and then we have something called declarative and functional. Honestly, declarative isn't too hmm, pretty vague, so we'll just keep that definition for now. I don't want to confuse you guys. And then functional is simply focuses on functions and immutability, which simply means that you won't change the data. More than data, you like maybe make copies of it and apply different functions on that data. But your source information is not edited at all. But yeah, all this is absolutely not important. What we'll be focusing on now is object oriented and procedural, right? Again, to reiterate, procedural is step by step and object oriented, I'm sure we all know, focuses on classes, objects, functions, etc. So moving on, object-oriented programming. Now, according to these beautiful notes, we will first look at what procedural programming actually is and its major flaws. So by knowing these flaws, we can know what object-oriented programming fixes, right? So procedural divides the program into a set of functions and the data stored in a bunch of variables. So you have like if you remember in Python, we'll always give something like a is equal to 5, b is equal to 3, and then we'll simply have a print a plus b or something like that. So notice how all of these are jumbled. There's no like set container. Yeah, sure, there are like stuff like sets and what to say, sets, dictionaries and all that, but those are types of containers that holds data. There is no like set class that holds all this data together. So I can't access all of these in the same format in a way. So, and similarly, all these functions, while you can define them, you can't access them. You can't say, oh, okay, this function will only work for a certain group of variables. So if I have something like this, and then I have C as 4, D as again 5 or something, this plus operator will work for all of these. I can't exclusively say, okay, only work for these group or anything like that. So those are the main problems we have with procedural. All the functions and the data are all a bit scattered. There's no like set way. They're stored in a bunch of variables. They're all so you can see this box. They're all just shoved in there, right? So this is what object-oriented programming fixes. So this box will make multiple more boxes and make it exclusive. So no specification on what function operates on which kind of variable. So if you notice on Python, you can add decimals, you can add complex numbers, you can even add certain types of strings. So there's no set definition, which, as you remember, we have defined these functions for object-oriented programming, but yeah. So the functions are also interdependent. So modifying one might break the rest of the program. So if I suddenly change a particular variable or a value, since it's step by step, it doesn't like assist the entire program as a whole. So if I do something in this first step, it might affect some other logic I might have at the end. And then, so we also have to deal with function parameters and arguments, which is something we still deal with. But if you really want like all this exclusiveness that I mentioned above, you need to work with a lot more parameters and arguments, which at times can become annoying, right? So all of these are the current problems we have with procedural coding, which is stuff like Python or something, right? So to fix this, we use object-oriented programming. Because in object-oriented programming, we have a concept called classes and objects. Yeah, sorry. In object-oriented programming, we have classes and objects. So in OOPS, we combine related functions and variables and put them in blueprints called classes. So essentially, in OOPS, you make a box and say, okay, this box will have a certain number of variables and certain functions. And all the copies of this box will inherit these at the same time, and they will have the same properties. And within this, we can also mention that certain variables or functions will be private and certain can be accessed by anyone from the outside. So all this I will go into detail. But yeah, so in OOPS, we combine related function and variables into blueprints called classes. So this is essentially what a class looks like. And you can see there are variables and functions. And this is another class. So you notice how these functions and this variable is separate from these. So this is the primary idea or the primary thought behind object-oriented programming. An instance of the class would be an object. So I have defined this class, right? And if I make, let's say I make a car class and I say inside, okay, it'll have the vehicle number and then the functions would be accelerate, decelerate, something like that. So every copy of this I make would be called an object. So I can have car one, car two, stuff like that. So I could say human is a class, and me, my classmates, my friends, all of us would be like objects of this human class. So yeah, that's what they mean. An instance of a class is an object. If you want a more computer science example, we have integers, right? So integer is a sort of class, and any integer I make 5, 6, 8, something, these would be considered objects. But there are certain nuances, but this is just an example, yeah? So the variables are called data members and the functions are called member functions. These are just fancy names for these variables. So you see the X's are essentially data members because they're members of the class and they contain data. And with this data, we would perform certain functions. Yes, so that's why we call them member functions. The members or the functions. Yeah, you can just remember them as properties and methods, to be honest. But yeah, once you, I'm sure all of us know the name by now, but yeah, if you ever forget, just remember data and functions, right? Now, by using this, obviously we make the program more organized. So you can see like the difference in like the organization here and having something like this, like if I put 50 more X's and F, it'll become confusing, yes? So yeah. Now, yeah, so here is, they've also defined the car class. And these would be variables, yes, in a way. So these are my data members, and these are functions. Yes, you can say that they're functions with the two brackets. So these are member functions, and they're also called properties and methods. So in this car class, essentially, I'm saying every object of this car class will have these properties. So each car will have a brand, a model, a color, and each car can accelerate or brake. So this is what a class essentially defines. And if you want to visualize it, this would be the optimal way. Now we can create an instance. Instance is simply object of the car class to depict a certain car. So you notice how we have car 1 and car 2, right? So I said that each should have a brand, a model, and a color. So car 1 has the brand Honda, a model Honda City, and the color gray. Similarly, you have a Swift Suzuki here in the color of blue. And both of them would have these functions. So both of them can accelerate and decelerate. So these would be objects. And I can make an infinite amount of objects. I can make car 3, 4, 5. I can even make copies of these objects. It's pretty versatile in that sense. Now, what are the features of OOP? So we have defined that OOP essentially sorts all our data and the functions pertaining the data into separate boxes, separate classes, yes? Now, there surely is more than this. Like, what is the essence behind OOPs? And that would include three topics, or essentially two topics called encapsulation and data abstraction. Data hiding abstraction are the same thing. But yeah, encapsulation simply means these boxes. So the way I sort specific functions and specific variables into these boxes makes it much easier for me to access and utilize and work with, right? So this is encapsulation. Now, data abstraction works with another topic, which I'll explain briefly now. Essentially, remember I told you I can give, so I have these. Let's say I have a number called the identification number of sorts. And while all of this can be publicly available, so I'm walking on the street, I can see that a car is a Honda City and I can see it's gray. So all that is public knowledge, right? But do I want everyone to know, like, my car, I don't know, purchase number? I don't. So I have the freedom in OOPS to make this private. Can't spell private. Oh my God, my bad. Yeah. So I have the freedom in OOPS to make this private or even protected, which I will talk about later. But this control over the privacy of the particular data structure, not data structure, sorry, the particular classes like variables or functions is what I would call data abstraction. Abstraction simply means hiding, hiding from people who don't need to see it, essentially. So, if you want the formal definitions, encapsulation is the act of bundling data and the functions into groups, as I mentioned, putting them into boxes. Classes are the implementation of encapsulation. This sentence is pretty explanatory. Now, what are the advantages? Member functions can have direct access to the members of the object. There'll be no confusion about the parameters. So let's say I have this class and I have A, B, C variables and I have function add and subtract. Now, as I'm sure you guys know that in C++, it's not as simple as Python, right? So in Python, no matter, you don't really care about what type of variable A, B, and C are. You can just add them and it'll do something, right? But with C++, you have to be much more fine-tuned. So each time you add a new type of object, you will need to define it. So when I use classes like this, my functions automatically know that, okay, I am a function in this house, in this class. So I can only interact with the members of this house. I can only interact with the members of this class. So this freedom makes it much simpler. So if you guys remember, like earlier up here, we had to define, is given here. Yeah. This is for procedural. We would have to deal with the function parameters and arguments every time, especially if you're doing something very fine, right? But here with encapsulation, since the function knows which variables it has to access, you do not have to mention it every time. So this is a nice advantage of using encapsulation. So the members have member functions have direct access to the members. So there's no confusion with the parameters. It won't look outside this class and think, maybe I need to work with that variable. No, it won't. So the member and member functions of a class and an object are independent of other classes and the object. So if I have two classes like this, and I have some variables here, functions here, variables here, functions here, this function won't go and talk with this variable, and this function won't talk here. And similarly, these variables won't interact with this, and these variables won't interact with this. They're like very exclusive unless very explicitly mentioned, which you don't have to like bother with now. We'll have that in a separate unit. But yeah, they are independent of other classes and objects. Now, this is encapsulation, yes? Now let's look at data abstraction. So data abstraction essentially means you're hiding it. So if you're a car mechanic, you're hiding from the client how you're building the car or how you're fixing the car. You're hiding all of that and you're just showing them the surface level, okay, it works. That's all you need to know. That's the idea behind abstraction. So you're hiding from the user all the complexity that you hide behind your code. Or you're hiding from the user the private details of your code, which is really important for like certain use cases if you're dealing with sensitive information, right? Like bank details, or like I mentioned, like the car purchasing number or whatever. So data abstraction simply means only having access to the top layer of operations rather than the internal membered variables. So you're only having access to the top information. Like whatever I am showing you is all you will see. Everything under that you do not have access to, or at least an external user will not have access to. So for data abstraction, you have three main keywords or three main types. That is private, public, or rather protected, and then private. So, oh, I'm sorry, public. So these words, I'm sure like you guys can guess. So public means anyone can access them. Protected means a specific mentioned group can like access them. So inherited classes, which you will see later on, and like friends can access them. So it is protected. It's not like publicly available information, but trusted sources can access this information. And private is completely, as it says, private. You do not have any external access at all, right? So implemented. Okay. Now, what is the advantage of such protection? So we will talk about simplicity. So without like worrying about what goes on inside. So as I said, sorry, this is like the advantages for abstraction, right? So as I said, a mechanic, they won't show the user how the car works, how it's running, how they fixed it. They would simply just show them that it works. And that's all you need to know. This makes it simple for everyone involved, so the user doesn't have to go through the pain of explaining anything to them, and the user doesn't need to go through the pain of understanding everything. So, without worrying about the internal work, the user can simply use the publicly available methods. So, all the user essentially needs is how it runs, what is the name, what is the color. They don't need to know like certain things. Okay, this is the gauge number used, this is the wrench I used to fix this, stuff like that. They do not need access to. So it makes the entire thing simpler for everyone involved, right? So as is mentioned here, in a car I can use these, but to drive it, you need all of this, right? Now, a normal user, let's just say for the sake of argument, won't really care about all this. All they want is this information. So this can be put into private or something, and this can be made public, as mentioned here, public. And this is private. So this immediately creates a barrier, a protective barrier between an external viewer and the person who works interior. Now, again, as I said, abstraction and data hiding are hand in hand, almost the same. So, making sure that internal variables are only accessible by the member functions, as I've discussed before. And this would be with a private keyword, as I mentioned. So if I give these a particular keyword private, only the internal variables are accessed. So someone from the outside, I can't, let's say this is a car class and I make car one. I can't externally say, show me the wheel type of car one. That will show me an error. But as an interior worker, like let's say as an engine or something, I can ask, okay, I need to know the wheels, and I will get that information, right? So now, what is the advantage of this? Again, dealing with sensitive information would be our top advantage. So, and the other would be internal values cannot be directly manipulated. Now, as we've seen before, if I have my wheels as a private class, I, as an external user, can't. It's like going on the street, right? If you see a car there, you as a user, you can't just decide, okay, I'm going to change the type of wheels on that car. You have to be someone who owns the car to decide what wheels it will get, right? That is a pretty vague understand, like explanation of how private and public work. So the internal values, that is the wheels, cannot be manipulated via public functions. So I, as a third party, cannot go change the wheels, right? So same one as data abstraction. Yeah. So here, if I define these as private, I understand this is repetitive, I'm sorry. But if I define these as private, these like public functions really can't access them, right? So, and security, yes. This is just a repetition, ideally private, and these are public methods. Now, quick notes on private and public just to drive home the point because this is important to understand. The private is very formal definition here. A data member or a member function that is declared private. So you will have the private keyword whenever you define them is only accessible within the scope of the class. So if this is my class, only the members of this class, the functions of this class, can access this particular private data type or function. I, as a third party, in like, let's say the code, the main code, I cannot access this at all. Okay. And public would be vice versa. I, as a public party, can access the code. So any data member or member function that is declared public can be accessed or used outside the class as well. Okay. Now, let us say I have some admin status, right? Let's say, so for the car example, let's say I was in the police or something, right? I will need to have certain permissions. But even with that admin status, I don't need all the information in lieu of abstraction and whatnot. So that is why I have something called getter and setter functions. So get and setter functions essentially get and set the values, private values, which I have permission to access. So a function that returns the value of a private variable is getter. So I have to have this permission to access a getter and setter, which can be defined easily by the user. And setter simply means a function that modifies the value of a private variable, right? And these would ideally be public methods. I hope that is fine now. If you want to ask why, it prevents direct and undesirable manipulation, as it's pretty obvious. That's why we're using private. And you can control which data goes out. So if you particularly define that, okay, only this particular user gets the getter or setter function, or only this particular snippet of code gets to use it, you can control. Okay, so if an undesirable change happened to my private variable, it's most likely out of this. And it removes confusion with internal variables. Now, let's say I do want to change it, but I can't. So I'll go back, maybe make another, or go somehow internally and change it. It removes all that unnecessary confusion, right? Any doubts so far? It has been pretty basic. It's all topics we have covered time and time again. But any doubts so far? Okay. Now, UML class diagrams. UML class diagram stands for United Modeling Language, I guess. So these are essentially going to be a way of representing my classes so that anyone externally can understand. And it's also a way of planning out how my object-oriented program would look like, or what structure unified, my bad, unified modeling language. So essentially, it helps me flesh out, just picture the structure of my class and all its member functions and variables before I actually get started. Or if I want to show someone and to give them an idea of how the layout is, I can use UML class diagrams. Now, this in detail will be like covered in Unit 5. We do have a unit for this exclusively, but we will look at like a very basic representation. So it's a way of representing an object-oriented program logic structure. So if you see here, usually this is a class, right? It's represented with dotted lines. This would be the name of the class. Now, minus means private, private functions or like private member, like it just has a private tag. And plus means it's public. Now, if I define it, you can define it this way, or you can also say in account number. This also works. This is also a nice variable definition, but this is accepted as well. So this just talks about the data type and the data name. So these are all data members. And these would be data functions. So you can call them functions because they have your brackets. And this is a parameter. These are the return types. So this you can also represent as pool deposit. This works too. They're not too particular on this representation. What you have to make sure is the return type is like mentioned clearly. The name of the function is mentioned clearly. And if it has any parameters, those should be mentioned clearly with their type. And one of the most important would be whether it's private or public. What about protected? You mean the symbol? Harshita, do you mean the symbol? I can't see chat. One second. Yeah, okay. Oh, the symbol for protected is a hashtag. Hashtag. Same for if you protected functions are pretty rare. I don't think I've ever come across a protected function, but those will also use the hashtag. Now, what is a UML diagram? As we saw before, it's a logical structure and behavior of a class. So it has a list of all the member functions and the data members, whatever. Now, why do we have them? As I mentioned before, it's good for planning, representation. If you want to give someone like, idea of how your structure looks like, it's really good for that. Now, it helps understanding the logic without any syntax necessary. And we are done. Any doubts with the UML side? Okay, so that's it for Unit 1. So just to give like a small idea of the units for today and tomorrow. I'm pretty sure Udayana will be taking Unit 4 tonight. And then tomorrow they'll be covering Unit 2, 3, and 5. Unit 2 and 3 is taken by Srivatchan, but not sure about Unit 5, but that's generally the idea for today. And tomorrow the class will be in the morning because seniors thought that we would prefer that as it will give us more time to like revise and you won't have too much repetition in case you studied in the morning, you're studying the same thing in the evening. And But yeah, any doubts with Unit 1 or any questions you want to discuss in particular? It is a pretty basic unit. It is introductory, but anything. Okay then. Thanks for attending, everyone. Yeah. Bye.